Good morning, everyone. I welcome you all for this new method of teaching and learning process. We call it as an e-learning process. This is we are going to have due to the effect of COVID-19. So we in this particular teaching and learning process, we are going to discuss regarding water supply and treatment engineering with the subject code 18 CV46. We have already completed 1.5 module. In module 1 we have discussed regarding what are the different types of water demand and its different types, and then factors affecting per capita demand, then variations in the water demand, then the different methods of population forecasting, and then design period and problems on population forecasting. In module 2 we have discussed the objectives of water treatment, unit flow diagrams, then sources and characteristics, and sources and subsurface sources of water supply, its suitability, what are the different sampling techniques, what are the precautions we need to take, we have discussed. Then now we are going to discuss in module 3 regarding sedimentation and filtration process. I repeat, we are going to discuss regarding sedimentation and filtration process. In the sedimentation process we are going to discuss regarding theory, then what are the different types of settling tanks, different types of settlings. We are going to discuss regarding design. We are going to discuss regarding coagulation and flocculation, clariflocculator, then different types of coagulants, then different types of feeding devices, what is jar test and estimation of coagulants. This is, if we cover this, we are going to cover sedimentation. Then we are going to discuss regarding the filtration, what is filtration, then theory of filtration, then different types of filter, slow sand filter, rapid sand filter, pressure filters, problems on filters, then a design of a slow and rapid sand filter with its drainage system. If you are, after this particular explanation, we are going to give you the notes on this particular module. If you are going to have any kind of doubts, you can contact me on WhatsApp. In module 2 we have discussed regarding what is screening. Screening is, in order to remove, we are going to remove the larger floating elements in this and how it is helpful and all we have already discussed. Then we have discussed aeration. In this particular module we are going to, as I have told, we are going to concentrate more on sedimentation and filtration. After this we are going to have disinfection and miscellaneous. Now we are going to concentrate on sedimentation and filtration. Now regarding sedimentation process, first of all we need to know what is turbid water, and this turbid water we are going to have it from the precipitation. Now precipitation is nothing but a rainfall. When the rainfall is going to occur, the precipitate, whatever it is going to flow, it is going to be flowed down first on the land surface and then it is going to enter the water source. Either it might be lake, river, anything, right? It is going to fall on ground surface first, and then if the slopes are there, then it is going to form a water body, and then in this water body, along the soil particles along with water, it is together, the soil plus water together makes it as a turbid water. That is, turbid water is, I repeat, soil plus water. This is nothing but the turbid water. Now what is sedimentation process is, now already we know the mixture of soil plus water is nothing but the turbid water. Now in the sedimentation process what we are going to do is, in the sedimentation process we are going to take this particular turbid water in a tank. We are going to take it and we are going to give for this particular stored water, this is the turbid water. In this water we are going to store in a tank for a certain amount of detention time. Detention time is nothing but for how many or for how much time we are going to store this particular turbid water in the particular tank. That is nothing but called as a detention time. After storing it for a certain amount of time, say for example 3 hours, after 3 hours, whatever, if the before the detention time the water was in turbid condition, now after giving certain amount of detention time, that means the water will be completely under rest, it will be under a stationary condition. After the stationary condition, what will happen is these these turbid water, the soil particle will be having the some amount of specific gravity to it. These specific gravity, due to this specific gravity, what happens is these particles are going to get settled down by its own weight. After settling it down, what will remain here? Here it will be clear water after certain amount of detention time. So the sedimentation process is the process of allowing the water in a tank for certain amount of a duration time. After this particular duration time, what will happen? The particle will settle down by its own weight and getting out the clear water at the supernatant layer is called as the process of sedimentation. Now, in order to remove these suspended and settleable soil particle, we need to have this particular sedimentation process. If we don't have this particular sedimentation process, what will happen is these soil particle, that is settleable and suspended particle, it will further continue in the water treatment plant, and it is going to create a problem in the, like a choking problem, as well as the water will remain turbid if we don't remove these kind of a suspended particle. So that reason what we are going to do is we are going to do this particular sedimentation process. Till now we have seen what is sedimentation, what is detention time. This is that was a very important concept to understand what is sedimentation. Now we are going to see what are the different types of sedimentation. There are two types of sedimentation. One is plain sedimentation and one is coagulation sedimentation. Now what is this plain sedimentation? That is, I have already told, the sedimentation without plain sedimentation is if we allow the water to stand in a tank for a certain amount of time, that is detention time. After giving some amount of detention time, the particle are going to get settled down by its own weight. Remember, plain sedimentation is nothing but it is with a given detention time. After giving the detention time, what will happen? The particle are going to get settled down by its own weight, and again at top we are going to get the supernatant liquor. We are going to get it as a clear water, that is nothing but called as a plain sedimentation, or we also can say without adding the coagulants, that is nothing but called as a plain sedimentation. Now next process is the coagulation sedimentation. It is, see, this particular method we are going to use it for the suspended particles, the particles, those who are always going to remain in suspension. In order to remove such kind of a particle, we use this particular coagulation sedimentation. We are going to add the chemicals. Here we are going to add the chemicals like alum, copperas, chlorinated copperas, such kind of an element we are going to add. So we use it for the particles which are not going to easily get settled down by its own weight. Plain sedimentation is for the particles which can get settled down by its own weight, and here it is for the particles which is not going to get settled down by its own weight. We use coagulation sedimentation. Now this, after having the learning plain sedimentation and coagulation sedimentation, theoretically we have shown you the diagram of that. In the plain sedimentation, the particles which are going to settle down by its own weight. So these are the particles, if after giving certain amount of sedimentation time, the particles have been settled down, and this is nothing but the clear water that we have got. This is the plain sedimentation without adding any kind of a chemicals. Now the important aspect regarding the coagulation sedimentation is the particle who are not going to get settled down by its own weight, or they are going to remain in suspension. The particles cannot be removed by the plain sedimentation. So for such kind of a particles, we are going to use the coagulation sedimentations. What happens is these particles will always remain in suspension, and after adding alum, this is different charge and this is differently charged. So after having the differently charged bodies, when they are differently charged, what will happen is these react with each other, and since they are oppositely charged, they attract, and then what will happen is these suspended particles, they come together and increase their shape as there is a force of attraction is going to be created between the water, the alum with water and these suspended particles, they are going to form a ball like structure. We call it as an float. Remember, we call it as a float. The suspended particles, after adding the chemicals, they interact with each other since they are oppositely charged, and they will come closer together and forms the ball like structure. When the ball like structure are formed, what is going to happen? The specific gravity of these particles is going to increase and they are going to get settled down by its own weight. So what will happen? It is going to give the turbid water at bottom, and at top we are going to have the clear water. So this is nothing but coagulation sedimentation. These also is going to be asked in your exam. What are the different types of sedimentation, or explain plain sedimentation or explain coagulation sedimentation? It will be asked in your exam. So at that particular time you need to give such kind of an explanations with the diagrams. Now our next topic is the types of settling. In this we are going to discuss regarding type 1, that is a discrete settling, type 2 hindered settling, type 3 zone settling, type 4 compressed settling. In order to explain the different types of settling, what we need to have is, we need to take one particular cylinder. In that particular cylinder we need to add some quantity of water and some quantity of the soil. After adding certain quantity of soil, what will happen is, the particles which are going to get settled down by its own weight, they are going to immediately get settled down, and it will become the compressed settling. Here we are going to get more turbid water. These are having the settleable particles with it. Then here the concentration of particles will be more, and this will be turbid water. In the zone settling, what will happen is, there are some few amount of settleable particles will also be there, and some amount of suspended particles, but more amount of concentration will be suspended particles. Here what will happen is, there will be, as compared to this particular compressed settling, the water will be having more amount of suspended particles. Next is coming to the hindered settling. The concentration of these suspended particles, as we come up, it is going to reduce, because the suspended particles is becoming less here as we come from compressed to hindered. And then coming to discrete, here the concentration of the suspended particles still it reduces as compared to the hindered settling. After giving some amount of sedimentation time, what will happen is, if we give some amount of sedimentation time, what will happen is, at the top we are going to get the clearer water. Now the next topic is types of settling tank. In the types of settling tank, we bifurcate the types of settling tank based upon, depending upon the method of operation. We are going to have the two classifications, that is a fill and a draw, and next is continuous. Based upon the shape, we are going to divide it into rectangular and circular type of sedimentation tank. Now in the fill and draw type of sedimentation tank, as the name is suggesting, fill and draw. Filling is, what we are going to do is, we are going to fill the sedimentation tank with the water for how many hours? We are going to store it for 24 hours. Now after 24 hours, as I have told, what will happen? The particles are going to get settled down by its own weight. After 24 hours, what is going to happen is, we are going to have the clear water at the top. Now what we have done till now, we have done the filling and we have given the 24 hours of detention time. So what had happened? The particle had got settled down and we remained with the clear water. Now till this was filling process and that settling process. After this, what we are going to do is, this water we are going to take it out. Now what we have done? We have done drawing, right? After drawing, what will happen is, these particles, the turbid water with some amount of settled particle, we need to clean it. For this cleaning, how many time we require? We require around 12 hours for cleaning. So totally 24 for settling the particles and taking it out, right? We are going to utilize 24 hours, and then again for cleaning process, this removal of turbid, we are going to take 12 hours for this. For totally, if we want to add the fresh water for this fill and draw type, how many hours we require? We require around 36 hours. How much hours? We require 36 hours to again keep it in operation. So this is your fill and draw type. Then coming to the continuous flow type of sedimentation tank, as the name is indicating, it is having the continuous flow. Now here what we are going to do in this particular tank is, we are going to have the water in a sedimentation tank, but it is going to have the inlet and outlet. Here what we are going to do is, we are going to control the velocity. If the velocity is more, suppose if we are going to pass the water from here, if the velocity is more, then what will happen? If the water is turbid, then if the velocity is more, again what will happen? As we have passed the water with the greater velocity, say 1 meter per second, or say 30 meter per second, or say 100 meter per second, or any velocity, if we are going to cross it with the greater velocity, what will happen? The particle, we have not given sufficient time, detention time, or with the velocity is more. Due to that, what is going to happen is, the particle are straight away, it is going to come over here. It is not going to get settled down by its own weight. But when we are going to reduce the inlet velocity, that is at 0.3 meter per second, that is a slow, very slow velocity. So what is happening? If the water is turbid here, the particle are, since the velocity we have reduced, what is going to happen? The particle slowly, it starts to settle down by its own weight. And here the water we are going to get continuously. We are going to get the water continuously. Why we are going to get water continuously? We are going to maintain that velocity of 0.3 meter per second. So particle will get settled down, and here we are going to have the less turbid water at the outlet. So this is nothing but called as a continuous flow type of sedimentation tank. The flow is continuous, since we are going to maintain the velocity less, that is 0.3 meter per second. The next type is depending upon shape, that is a rectangular and circular shape. Regarding this, we are going to study in the next class in detail. We are going to study regarding these two types along with their diagrams. Now we are going to revise the things what we have learnt in this particular class. We have learnt regarding what is sedimentation. Sedimentation is nothing but the process of allowing the water, turbid water, to allow to stand in a tank for certain amount of time. After giving the certain amount of time, detention time, what is going to happen? The particles are going to get settled down due to its own weight. That is nothing but, after this particular process, what will happen? The particle are going to get settled down, and here we are going to have the clear water. So this process is nothing but called as a sedimentation process. Why we are going to do it? If we are not going to do it, it is going to cause the choking problem, and the turbidity won't be easily removed in water. So this particular thing, if we want to do, we definitely want to have the sedimentation process. Then we have discussed what are the different types of sedimentation, that is plain sedimentation and coagulation sedimentation. Plain sedimentation, we are going to do it for the particle which can be easily get settled down by its own weight without adding any chemicals. Coagulation sedimentation, we are going to do it for the particles which are not going to get settled down easily by its own weight. For them, we are going to use some chemicals. The particles which are which are going to remain in suspension. That is nothing but we are going to have, for such kind, we are going to have the coagulation sedimentation. Then we have discussed regarding the different types of settling. Type 1, discrete settling, hindered settling, zone settling, then compressed settling. Then this diagram, they may ask you in exam, they may ask what are the different types of settling, they may ask different types of sedimentation, they may ask you in exam. Then we have discussed regarding settling tank, types of settling tank, that is based upon the method of operation, fill and draw, and then continuous based upon shape. We have discussed, now we are going to discuss rectangular and circular. Fill and draw, we are going to take water, we are going to add it, we are going to allow it for 24 hours. The particles are going to get settled down in that 24 hours. Then we are going to take fresh water outside, and then we are going to have this, we are going to take this turbid water. It requires around 12 hours. So totally, if you want to keep in operation, it requires 36 hours. This you have to keep in mind. Then continuous flow, what we are going to do in continuous flow, we are going to take the water into a sedimentation tank, which is going to have inlet and outlet. Then we are going to reduce the velocity, that is 0.3 meter per second. Due to this 0.3 meter second, velocity is going to reduce. Due to this reduced velocity, the particles are going to get settled down by its own weight, and then we are going to get the turbid water downside, and the water we are going to get continuously here at the outlet. This is nothing but continuous time. So this is what we have discussed in today's class. If you have any doubts, you can contact me on my WhatsApp, and detailed notes will be provided to you after this particular class.